All right, this lesson is going to talk about dividing integers, and you're going to find that just like multiplying integers, positives and negatives, dividing them is very, 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 very easy. So real simple. This first blank here is dividing with different signs, and the reality is, what kind of quotient will you have? Well, just think back to multiplication. If one of them was positive and the other was negative, then the product would be what? And hopefully you're thinking negative. Well, it's the same thing here. If one of them is positive and the other is negative, then the quotient is going to be negative. So simply speaking, a negative divided by a positive is a negative, and a positive divided by a negative is a negative. So notice again, when the signs are different, the result is negative, just like in multiplication. Pretty simplistic, pretty easy. All the rest is just regular old division. So let's take a look at a couple examples here. So you got a negative in the first example divided by a positive. Negative divided by a positive is a negative, and we all know 28 divided by 4 is 7. Second situation here, you've got a positive divided by a negative, right? I'm looking here at B. And so 36 positives divided by 6 negatives. So positive divided by a negative is a negative, and 36 divided by 6 is 6, and that's a negative 6. All right, now be careful. Don't forget about order of operations. A fraction bar does act like a grouping symbol, and so we do need to take care of this on the top. Now, it's been a couple days since we dealt with positives and negatives. When you see this, what are you thinking? I hope you're not thinking subtraction. Get that out of your thought process. This is what you should be thinking. 3 negatives and 12 more negatives for a total of 15 negatives. Here, let me write it this way for you. For a total of 15 negatives, right? So what we really have here is negative 15 divided by 5. Negative divided by a positive is a negative. 15 divided by 5 is 3. And the quotient is negative 3. Hey, that's pretty simplistic. That's pretty easy. That's what we're talking about here. Let's do a few more. Again, feel free to pause the video right now and do these on your own, and then you can turn it back on and see if indeed you were correct. All right, so be careful. 20 on the top, and again, this is 7 positives and 12 negatives. 7 positives and 12 negatives leaves you 5 negatives. Positive divided by a negative is negative. 20 divided by 5 is 4. E. 18 negatives and 3 positives leaves you 15 negatives. On the bottom, 7 negatives and 12 positives leaves you 5 positives. Negative divided by a positive is a negative. 15 divided by 5 is 3. Even if you go back to the elementary division symbol, not to worry. We have a negative divided by a positive. That's a negative. 50 divided by 10 is 5. And therefore, the quotient is a negative 5. Look, that's the concept and that's the idea, and so not very difficult to deal with. Okay? All right, let's look at a few other things. So how about if we're going to divide with 2 of the same signs, right? So dividing with the same signs. And look, we know a positive divided by a positive is a positive, and just like in multiplication, a negative and a negative is a positive. So let's finish our rule here. Pretty simplistic. Positive divided by a positive is always going to be positive. Are you positive? I'm positive. He's positive. All right. And negative divided by negative is a, careful, positive. For the same reasons why a negative times a negative is a positive. So again, notice, just like multiplication, when the signs are the same, the result will be positive. Makes life pretty easy. Look at the first example there, A. Negative divided by a negative is a positive. 20 divided by 4 is 5. Quotient is 5. B, again, we've got an in-between step here. 2 times a negative 28 is a negative 56 divided by a negative 8. Again, negative divided by a negative is a positive. 56 divided by 8 is 7. And we end up with 7. Again, with the elementary division symbol, negative divided by a negative is a positive. And we all know that 121 divided by 11 is indeed 11. Hey, pretty easy. None of those are too hard. Let me deal with a couple special cases here with our last segment. So a couple special cases. I find that sometimes students struggle with dividing 0 by something. So the way I say it is 0 divided by anything. Right? So for example, what if I had 0 divided by 5? Now it's important that you understand what division is talking about. And there's a couple different ways to look at it. One way is this. How many 5s fit into a 0? How many 5s fit into a 0? So let me just pause for a second before we finish answering that question, and let me give you a couple other simplistic examples. All right? Let's suppose we had something like 12 divided by 4. Now we all know the answer is 3, right? Because how many 4s can fit into 12? Well, 4 plus 4 plus 4. 3 4s fit into 12, and the answer is 3. How about if we had something like this, 3/6? How many 6s fit into a 3? Only half of a 6 fits into a 3, and that's why that's a half. Do you see how that works? Do you see what's going on with division? So here's the point. Let's go back to our 0 divided by 5. How many 5s fit into 0? And the answer is none. 0 divided by anything is 0. 0 divided by 7, 0. 0 divided by -2, 0. 0 divided by the square root of 37, 0. 0 divided by any real number except for 0. All right? It's the only exception. So when I say anything, anything except 0. 0 divided by anything except 0 is 0. I don't care if you're talking about a rational number, an irrational number, a natural number, etc. 0 divided by anything except 0 is indeed 0. Now let's deal with it the other way. And this is how I illustrate this. And if you were in my classroom, I'd be at the door and I would say, all right, the room represents a number. And I'm going to say, let's let the room represent 10. And I'm going to start chucking in 2s. And you tell me how many 2s I can chuck. You tell me when to stop when the room is full. So I'll throw in the first 2. And the class doesn't say stop. And I'll throw in the second 2, and it doesn't say stop. And I'll throw in the third 2, and it doesn't say stop. And I'll throw in the fourth 2, and it doesn't say stop. And I'll throw in the fifth 2, and they'll say stop. And I'll say exactly right. 10 divided by 2 is 5. I can fit 5 2s into my space of 10. And then what I'll do is I'll change it up. And I don't know, maybe I'll do something like 20. And I'll say now the room is at 20. I'm going to throw 5s in. You tell me when to stop, and I'll start throwing in 5s. And of course, after 4 5s, they'll say stop. And then I'll do something like this. Let's take like the number 3. And I'm going to start throwing nothing in. You tell me when I fill up 3. I'm going to throw nothing in. So I got nothing. I'm trying to fill up a space of 3. I'm going to throw in nothing, and throw in nothing, and throw in nothing. When would you tell me to stop? And I hope your answer would be never. How do you say never mathematically? Can you say it more technically? I hope you're thinking this. How about infinity? Anything divided by 0 is infinity. In other words, I can put an infinite amount of nothing in anything. Now, courses don't like to say infinity because they want division to be reversible by multiplication. And it's not. But that's okay. Infinity is indeed a reality, and when you get to calculus, they'll tell you that. It's kind of what calculus is based on, that principle. But in the meantime, you also have to be aware that we like to tell students to say it's undefined. So usually a U or the word undefined. So anything divided by 0 is undefined or infinity. All right. And again, do you see the difference? Look, 0 divided by anything except 0 is 0 because you can't fit anything into 0. You can fit nothing into 0. You can fit 0 things into 0. However, how much of nothing can you fit into anything? And the answer is an infinite amount, or because you can't reverse it with multiplication, we'll say it's undefined. Hey, that's the idea. All right, so division, very, very easy. Remember, if the signs are different, the quotient is negative, right? And I'm looking right up here at the top. If the signs are different, the quotient is negative. And if the signs are the same, the quotient is positive.